I think most of you are neat. Neat, raise your hand. अच्छा हुजैफा
Yes, sir.
आपसे तो पूछना भूल ही गए हम सवाल. हाँ.
Yes.
Okay, हुजैफा, tell me what are the three types of defects in ionic crystals? Three types of defect in ionic crystals. Notes लिखा है आपने? हुजैफा?
Not all,
हाँ?
sir. Some.
No. वाह 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 वाह. 2 क्लास तो लिया है, 2 या 3 क्लास के लगभग लिया है हमने, जिसमें एक आप लोग कैसे हैं. आई गेव यू टाइम ना लास्ट क्लास में, आधे घंटे पहले छोड़ा था ना हमने. हाँ, तो भूल ही गए. उस पे भी नोट्स नहीं कंप्लीट है आप लोगों के. सही है. हाँ, वेरी गुड. अच्छा, सैफ एंड खलील, आप यू हैव रेज्ड योर हैंड. व्हाई? बाहर जाना है आप लोगों को या नीट करना है?
No. It's about neat, sir.
नीट ना. नीट ओके फाइन. तो उसमें तो आएगा ना, यू विल हैव सॉलिड स्टेट देयर, राइट? एटलीस्ट कुछ तो करके जाइए. ऐसे आप लोग अगर छोड़ दीजिएगा तो फिर सब कुछ भूल जाइएगा. ठीक है. कंप्लीट योर नोट्स. सोल्यूशन स्टार्ट हो जाएगा, फिर सोल्यूशन के नोट रह जाएंगे, है ना. इस तरह से मत लेके चलिए प्लीज. ओके, सो लेट अस स्टार्ट द क्लास, दैट इज सोल्यूशन. Solutions. Okay, now in solutions, what is solution? First of all, what is solution? Solution is, what is solution?
Solute plus
Solution.
solvent.
अरे वाह वाह वाह. लेकिन डेफिनेशन के हिसाब से दैट इज सो कंपोनेंट वाइज ना. दैट इज कंपोनेंट वाइज. सोल्यूशन में होता क्या है? सोल्यूशन में होता है सॉल्यूट एंड सॉल्वेंट. सोल्यूशन इज अ होमोजेनस मिक्सचर. प्लीज राइट दिस डाउन विथ मी. होमोजेनस mixture of two or more components. Two or more components. Now, in solution we have components. What are the components of solution? We have the component A, that is solvent, and I will write and I will denote solvent as A. जहां भी ये होगा, that means it is in the context of solvent. Solvent, it is component in larger amount. Component in larger amount. Okay, and then we have B, solute. I'll denote this as B, component in lesser or minor amount. Okay, so solvent will always be only one solvent, है ना. लेकिन you can have multiple solute. पानी में आप नमक डालिए और चीनी भी डाल दीजिए, ठीक है, and then नींबू भी डाल दीजिए. So you will have the solvent is only water, but the solute are salt, sugar, and then you have what I can say, the lemon also. That is also solute. You can write it as. Okay, so you have two components of solution, that is A and B. All of these things are old things that you must have learned in the 11th standard. Okay, now moving on, we have concentration terms. Now each of this solution, these are defined and their characteristic is the concentration term. How much solute is present in how much solution, or how much solute is mixed with how much solution, how much solvent. Okay, so we have this term, that is concentration terms. Now we'll learn about concentration terms. Concentration terms. In concentration terms, the first term that we'll be learning is mass percentage. Now these are the things that is of 11th standard. I hope you can remember some of this. Mass percentage, it is given by percentage. It is also given by W by W only. Okay, W by W. Okay. What is mass percentage? So W by W, mass percentage is equal to mass of a component divided by total mass of solution into 100. Okay, into 100. Let us suppose we have, let us suppose we have a solution with WA amount of A and WB amount of B. We have a solution in which we have A and B, and we have WA amount of A, and we have WB amount of B. So mass percentage of A will be equal to how much? Mass percentage of A, it will be equal to the mass of A divided by the total mass of solution. So in solution we have W of A also plus W of B also into 100. This is one thing in order to calculate. Now another is, if you have been given one information, for example, please don't write now, please listen. Okay, all of you, please leave your pen and listen. If you have been given a statement, for example, 10% of 10% W by W of NaCl, and you have been written aqueous in bracket. Okay, NaCl aqueous. Now what does this mean? It has a meaning. It means that 10 gram of NaCl is present. 10 gram of NaCl is present in 100 gram of solution. Similarly, this will also mean 10 gram of NaCl is mixed with 90 gram of water. Okay, so both of these lines, this translation of a very chemical statement, 10% W by W, it is a chemical statement of NaCl. You have to translate it into normal English in order to understand it in a very good way. So what is the translation? 10 gram of NaCl is present in 100 gram of solution, or 10 gram of NaCl is mixed with 90 gram of water. Please write this down. Let me know when you're done. Mass percentage.
So can you scroll up?
होमोजेनियस मिक्सचर तो लिख लिया होगा आपने, नहीं? Yes or no?
Yes, sir. Yes, sir.
ठीक है, components से लिखिए. Components of solution, the topic is okay. Solvent component in larger amounts, solute component in minor amounts. Raise your hand when done. Okay, please write it down. Raise your hand. Hello. Can you write about volume percentage on your own? Yes, guys, tell me. Atif, Fishma, Shravya,
Yes, sir.
है ना? Please write it down. Okay. खुद से लिखिए. अगर खुद से लिखिए याद करने की जरूरत नहीं पड़ेगी आपको. ठीक है? Write this down. Volume percentage. Look at mass percentage.
Take milliliters, right?
हाँ, ml. ये हम लिखा देंगे. यहाँ तक आप लोग लिख लीजिए. ठीक है? You write till here. जहां तक notations है. These things I will write it down. जहां तक notation है, definition है, वहां तक आप लिख लीजिए. Examples हम बता देंगे. Okay, raise your hand when you're done with volume percentage. Now, all of you, please lower your hand. Raise your hand when you're done with volume percentage. I will not write volume percentage. You have to write, and then you can ask me something. यहाँ क्या लिखेंगे? But I will not tell you. I will not write on my own. Okay. You have to write. Yes, yes, Shravya, you don't need to ask me these things. You have to mass, you just remove the mass and write their volume, है ना? And wherever you have W, just write their V, and that will be the volume. Okay. No brainer. Okay, let me just. Okay, fine. I think most of you are done with volume percentage also. So see, in volume percentage, if you have been given 10 percentage V by V. Okay, so volume percentage is V by V. Okay, and if you have been given 10 percentage of V by V, 10 percentage V by V of ethanol aqueous. Okay, it means 10 ml of ETOH is a short form of ethanol. 10 ml of ETOH is present in 100 ml of solution. It also means 10 ml of ETOH is mixed with 90 ml of water. 90 ml of water. Now, related to this is another term which is used, that is mass by volume percentage. That is mass by volume percentage. Now, this is used if you have a solute which is solid, and if you have solute that is solid and you have solvent which is liquid, solvent which is liquid. Okay, and in this case, you will be writing like this. Let us say 10 percentage W by V of NaCl aqueous. In this case, you will be writing 10 gram of NaCl present in 100 ml of solution. Okay, or you cannot write here 10 gram of NaCl mixed with 90 ml of water. This is a statement that you cannot write. Okay, this is the statement that you cannot write, because when I am writing the previous statements, then I am doing some kind of addition here, right? 10 ml plus 90 ml is giving me 100 ml, right? So I can write 10 ml plus 90 ml. That is completely valid if I talk about mathematics. We have ml here also we have ml, but I cannot write like this, na? 10 gram plus 90 ml. You know that I cannot have addition. I cannot have addition between two different units. Yes or no? Physics class 11 chapter 1 unit dimension and measurement. I hope you have learned there, है ना? इस वजह से ये जो दूसरा स्टेटमेंट है वो आप नहीं लिख सकते हो, ठीक है? Write it down, then cut it. कभी भी आप लोग don't make this mistake, okay? Don't make this mistake. You can just talk about the amount of solute that is present in the complete solution. That is present in the complete solution. Is that clear, all of you? Yes or no? Please tell me.
Yes.
Okay, fine. Now, next we have done 2-3 things here, right? Oh, now let me give you one question.
1 minute, sir. Please go up.
1 minute. Yeah. Volume percentage आपने पूरा लिखा ना? Formula and all?
Yes, sir.
Okay. Write this down about mass percentage, mass by volume percentage. Those who are with me in like 11th standard, they must know this translations, right? You have a chemical statement, 10% volume by volume, and these are the English translation. Most of the times, whenever you are learning a new subject, you have to be very much acquainted, and you have to understand and absorb all the terms, है ना? तो आपको खोल के बिल्कुल meaning पता होना चाहिए सबका. Then only you will be comfortable and doing the numericals easily. Done, guys? Yes or no? Please tell me. Yes, Saif. Done.
Yes, sir.
Yes, sir.
Saif. Okay, fine. Now let us write a question. Let us write a question. Calculate the mass percentage of 6 into 10 to the power minus 3 gram of oxygen present in 1 liter of seawater. Seawater's 1 liter weight will be 1030 grams, because it is quite heavy because of salt that is present in seawater. Okay. So in seawater, you have this total amount, the amount of solution that is equal to 1030. So you can solve this as mass percentage. This will be equal to mass of oxygen that is present, right? 6 into 10 to the minus 3. And the mass of solution is how much? Mass of solution. Mass of solution into 100, right? This will be equal to mass of oxygen is how much? 6 into 10 to the power minus 3 divided by mass of solution that is equal to 1030 into 100. Please solve this. Let me know the answer in chat.
Sir, in the question, the weight given is the weight of the solution.
Weight that is given, yeah, that is complete seawater. So you have taken seawater, 1 liter, that is equal to 1030 gram. That is the solution. That we have oxygen present, no? And that is why the aquatic animals can breathe. Okay.
Okay.
Oxygen is present there. Yeah. Kavya, can you please solve it to 2 digits at least, 2 non-zero digits? Now, please solve it a bit more. We'll understand there is a mistake there. नहीं आतिफ, you also थोड़ा और उसको ये की ना, पूरा तो नहीं होगा, रिमाइंडर बच रहा होगा, राइट? हाँ आतिफ,
Sorry, sir.
you will be having some remainder. So this is not accurate, no? When you are dividing 6 upon 103 or 6 upon 1030, then there will be some remainder, ना? उसको पूरा solve कीजिए, at least 2 digits. Yes, Abdul Rahman, correct. At least you should have 2 digits, 2 non-zero digits.
So can you check the chat for a second?
Yes, Huzaifa, what did you say?
I messaged you about something. Can you check the chat?
I told you. Okay, you can.
Oh, okay, sir. I'm sorry.
हाँ, आपने पहले भी मैसेज किया था यार. Yeah, correct. So some of you are having wrong in the sense that the Sayyid Muhammad ने दो पर भेज दिया. Okay, yeah. Khalil, correct. So this is, you will be getting this as 5.8 into 10 to the power minus 4%. Yes or no?
Yes, sir.
All of you are getting the same thing? Those who are not getting this, please look, you will be having some minor mistakes in the calculation, okay? In the powers of 10. Now this seems very absurd, right? 5.8 into 10 power minus 4%. Okay. So that is why for the solutions in which the amount of solute is very, very less, very, very minute, chemists, they came up with a different concentration term. And that concentration term is known as what? Can somebody tell me? What is that concentration term known as? Parts per million. Parts per million, that is ppm. Parts per million, ppm. So what is parts per million? Parts per million is similar to the mass percentage, volume percentage, or any of those things, but it is in parts of component divided by total parts in solution. I'm writing parts because it can be replaced by mass and volume both. Okay, total parts of component multiplied by not 100, but rather 10 to the power.
The total parts of solution, right?
Not mass. Okay, total parts of component, total parts of solution. Sorry, not mass, parts of solution. Yeah, correct. Total parts of solution into 10 to the power 6. It is very similar to percent. Okay. So percent is what? Percent is per 100, per million, and it is parts per million. Very similar to percent. So in percentage you multiply by 100. In per million you multiply by a million. Now if you do the same calculation now here, now everything will be very humane. Now you can see ppm, it is equal to mass of oxygen, that is 6 into 10 to the power minus 3 divided by 1030 into 10 to the power 6. If you solve this thing down, you will be seeing that it is 5.8 ppm. Okay, it is 5.8 ppm. So now this is very easy to convey. 5.8 ppm. It requires less space also. And all of these things are important when you have concentration terms, and these concentration terms, these are used in industrial materials and industrial products also. So if you have to write something, you have to keep in mind many things about space also, how much printing space is there. And this looks absurd. No one will understand it in like when you say it ek baar mein. Now this term 5.8 in parts per million, it means that, okay, fine, if I have 1 million gram, then 6 gram will be of the solute. The solute is 6 gram percent there. Now this doesn't convey the same thing very clearly when I say 5.8 into 21 minus 4%. Yes or no, guys? Tell me. That is why this is usable ppm, and ppm is mainly used. I have seen this in paints mainly. In paints, they give the concentration of lead, and the concentration of lead should be not more than 90 ppm. It should be less than 90 ppm, otherwise it is poisonous. Okay, lead is poisonous. That is why it should be in low amount. Okay, please write parts per million. Let me know when you are done. Parts per million हो जाए तो बताइएगा. Yes, guys, parts per million. Done, all of you? Okay. Now write another question. So if you see this question here, you have been given the mass of solute, and you have been asked the mass percentage of oxalic acid, the solute mass percentage. Okay. Now the thing here is that you have not been given the mass of solvent. So mass of solvent is not there, right? So mass of solvent, it can be determined from the density. Since density is equal to mass by volume, and density it is equal to what? Mass by volume. So mass will be equal to density into volume. Density into volume will be the mass of solvent. So the total mass of solution will be, it will be equal to 11 gram plus you have the mass of solvent. Solvent mass is how much? 500 into 1.1. है ना? Yes or no? Okay, so you don't have to add mass of oxalic acid in solution. Okay, 500 ml solution is there, so you don't have to write this. Just need to write the mass of solution, because 500 ml is the volume of solution, not the volume of solvent. Okay, so you have mass of solution also, you have mass of solvent also, solute also, sorry, which is 11 gram. So mass percentage will be equal to 11 upon 500 into 1.1 into 100. So if you calculate this, you will get it as 2%. Please write this down. You'll get this as 2%. I hope you can see that. You can cancel these two zeros, right? And 1.1, if you multiply by 10, then you will get 11. And after that, you can also Cancel 5, 2s are 10. That is why it will be 2%. Yes, write this down. Let me know when you're done. Done, guys? Okay, so we will be moving forward. Okay. So you
1
have now
minute.
next 1 minute. Okay. Fine. Please start. आप लोग start कर दिया कीजिए, ठीक है लिखना. When you have the question now, then please start at least some parts of solution.
Done, sir.
Done. Okay, fine. Next is 5th one. That is molarity. Molarity. So what is molarity? The number of moles. It is denoted by capital M. The number of moles of solute per liter of solution. Per liter of solution. So M, it is equal to number of moles. Now B means NB. NB means number of moles. N means number of moles, and B means of solute divided by the volume of solution in liters. Volume of solution in liters. Now for molarity, the unit will be what? The units will be mole per liter. There is another, yeah, it is mole per decimeter cube. Okay, dm cube. Mole per decimeter cube. Now if you look at this NB, it is equal to what? It is equal to the mass of solute in the solution divided by its molar mass. So you can also write molarity. It is equal to WB upon the molar mass of this solute into the volume in liters. Okay, volume in liters. Please write this down. Let me know when you're done for molarity. Also, you can write a note. Write a note with me. As you can see, there is a volume element. Since molarity has a volume term, and volume is temperature dependent. Temperature dependent, and volume is temperature dependent. The molarity is also temperature dependent. Molarity is also temperature dependent. Done? Yes or no?
Yes.
Okay. Now there are a few other terms that is used. If you see, you have, let us say, for example, you have been given m/2 solution. So it means semi-molar. If you have semi-molar somewhere written, semi-molar solution of NaCl, that means it is what? It is m/2. Okay, semi-molar is m/2. You can have decimolar solution of NaCl, decimolar solution of ethanol. Decimolar is m/10. Decimolar is m/10. Then you can also have centimolar. You can have centimolar. This will be m/100. Centimolar is m/100. Then you can also have millimolar, right? Millimolar. So milli is m/1000. Okay. So remember these terms also. M/2 is semimolar, decimolar, centimolar, and millimolar. Okay. Before moving further on, I think we wrote this volume in liters, right? And then we can now do a question. Write this down.
Sir, 1 minute. Can you scroll up?
हाँ, क्या लिख रहे थे आप बताइए? Tell me.
That
What are you writing?
semimolar, decimolar.
Semimolar. Okay. Then next, the next line you write decimolar. Okay. Then you write centimolar, and then you write millimolar. Okay.
Yes, sir.
Okay, semimolar, and you can write the quantities also, right? Semimolar will be m by 2, deci will be m by 10, centi will be m by 100, and milli will be m by 1000. Yes or no?
Yes, sir.
Okay, great. चलिए. अच्छा, एक और चीज, it means इसका मतलब क्या होता है? m by 10 and m by 2, these means that the molarity is 0.5, right? Molarity is 0.5, right? Here the molarity is 1 by 10 molar. Okay, so please remember these things also. That m by 10 का मतलब क्या है? चलिए, first of all write this question. Let me know when you're done. This is easy question here. एक information जो आपको हम देना चाहते हैं, that is 1 centimeter cube. It is equal to 1 ml. Okay, it is equal to 1 ml. You have been given the mass, you have been given the molar mass, you have been given the volume. So you can directly put the formula that molarity, it is equal to the mass of solute divided by the molar mass of the solute into the volume in liter. Okay, this will be 2.46 divided by molar mass is 40 into 100 ml. So this will be 0.1 liters. Okay, so this is grams, this is gram per mole. So the whole units will be mole per liter. Can you please calculate this? Let me know when you're done. Send the answer in chat. One answer. Okay, Shravya. Yes, I think that is correct. Waiting for others. Yes, Shravya, that is correct. Yes, Syed Mohammed, correct. Yes, Atif, correct. Yes, Hania, correct. Correct. Okay, fine. I think most of you are getting the right answer. The answer is 0.615 moles per liter. 615 moles per liter. Okay. So this is about molarity. Now you have a similar term that is, you must know of this, is molality. Those who have not written, please write this down. Molality. So what number is this? We have done molarity, 6th. Molality. Okay, so molality is given by small m. Molality is given by small m. Okay, what is the definition? Number of moles. Number of moles present in 1 kg of, or rather I should say per kg, not 1 kg is not a good word, per kg of solvent. So m, it is equal to number of moles divided by
Is it
Number of
solvent
moles
or
divided by
solution?
solvent row. NB divided by the mass of solvent in kg. So you can also write this as number of moles will be equal to what? The mass of solvent divided by the molar mass into the mass of, this is the mass of solvent in kg. This will be in grams. Okay, this will be in grams. The unit of molarity, it is what? Moles per kg. This is moles per kg. Okay, molality. Also, the note is that molality is independent of temperature, right? Why? It is independent of temperature, as it doesn't have any volume term. Okay, it does not have any volume term. Please write this down. Let me know when you're done. What about others? Done? All of you? How many of you are done? Done now? Can I move? Yes or no? Okay. Most of you are done. Okay, fine. So let us do one question. Write this question. What is potassium carbonate? It is K2CO3. K2CO3. If you need any more information, just ask me. Atif is asking, you can't, नहीं इसमें तो आपको बस एक चीज का चाहिए होगा ना, right? You just need the molar mass for K.
1 minute, sir.
Yes, Shravya, tell me. You're saying something, Shrav? Hello?
No, sir, we're solving the question.
I can't hear you. K is 40, okay? K is 40. And I solved the question, not a problem. I was just saying that the molar mass for potassium is 40, okay? Yeah, I'll give you guys 1 more minute. Okay, Shravya, let me see. No. Okay. So what is the mass of solvent? Shravya, can you please write in chat? What's the mass of solvent that you took?
Sir,
No,
it
Mohammed.
was molarity instead of molality.
It's molality, na? It is molality,
It
okay?
is molarity.
Okay, fine. It is molality, not molarity, okay? Read the question properly, all of you. It is molality. Now, listen. In molality, what do you need? Molality is the number of moles in B upon the mass of solvent in kg. Now, you have not been given mass of solvent. You have been given the mass of solution and its density. So, sorry, the volume of solution and its density. Okay, I think Atif is somewhat nearby close. Atif, can you please like solve one more digit? At least 2 non-zero digit after decimal point, hai na? 2 non-zero digits after decimal point. Okay, listen. So here you have, here what do you have here? Okay, fine. Here you have mass of solution, sorry, volume of solution. So density is equal to mass by volume. So mass of solution will be equal to mass of solution will be equal to density, that is equal to 1 into 500, right? And similarly, mass of solvent is equal to mass of solution minus mass of solvent, correct? Mass of solution minus mass of solvent. So mass of solution is how much? 500 grams minus mass of solvent is 20.7 grams, right? I hope you can see that. So this will be equal to how much? 479.3 grams, 479.3 grams, okay? Yes, Khalil, correct. This is the mass of solvent. Now you need the number of moles. So number of moles will be equal to 20.7 grams divided by, I think it is 138, 132. What is the molar mass? 138 or 132 for K2CO3? I think it is 138.
138.
138.
Congrats. Okay. So, and how much this came? 0. This will be 0.14 or something, 1415. 207
0.1.
by 14.
Yes, sir.
Okay. 0.14 is the number of moles. Okay. And if you calculate this, the molality will be equal to 0.14 divided by 4793. Now, so you can write it as 0.48 kg. Okay, and if you solve this, this will be somewhere around 0.313 moles per kg. The important thing was this here. Mass of solvent is equal to mass of solution minus mass of solvent. Oh, mass of solute. Solute लिखना था हमको यहाँ पे, sorry. Mass of solute. Okay. All of you done? Yes or no? Please tell me. All of you done? Okay, seems all of you are done. Now moving on. The next thing you have here done molality. Seventh concentration term is mole fraction. Seventh concentration term is mole fraction. So if you remember mole fraction is denoted by a sign that looks like A, but we call this as chi. This is what?
Chi.
Chi. Chi. So what is mole fraction? It is the ratio of number of moles. Ratio of number of moles of a component to total number of moles, total number of moles of components of each component. So for example, in a solution of two components, solution of two components A and B, chi of A will be equal to number of moles of A divided by number of moles of A plus B. And chi of B, this
Number
will
of
be
moles.
equal to number of moles of B, yeah, correct, divided by number of moles of A plus number of moles of B. Also one more thing, chi A plus chi B, it is equal to how much? It is equal to how much? Chi A plus chi B is equal to 1. Very good. Okay. All of you know this, yes or no? किसी को नहीं आता क्या? I think you can remember this from class 11. जो हमसे पढ़े उनको तो याद होना चाहिए. I'm asking about others. Hania, do you know this? Yes or no? Sir?
Yes, sir.
Okay, fine, great. Chalo. Please write this down. Let me know when you are done. Raise your hand when you are done, okay? Since most of you are done. Okay, also you can see in mole fraction also it is not dependent on volume. That is why it will be also temperature independent. This will be not dependent on temperature. So write this one question. Calculate the mole fraction of ethylene glycol in a solution containing 20% of C2H6O2 by mass. Now this statement, it is a chemical statement. You have to convert it into English. Okay, so first of all, what you will do? Okay, please turn on your mic. Guys, please turn on your mic and tell me, how should I write this? 20 gram, please. 20 gram of 20 gram of, sorry, speak, yes, Sayyid Muhammad. 20 gram of
20 gram of C2H6O2 in 80 gram of
C2H6 in, or rather I should say mixed with, बताइए आगे, mixed with 80 grams of what? 80 grams of
Water.
कुछ नहीं दिया है तो water. Okay, if it is not there, then what is the universal solvent? If nothing is given, then it will be water. Okay, with 80 grams of water. So you will have to calculate the number of moles. Number of moles of C2H6O2. Then you have to calculate the number of moles of H2O. है ना? चलिए, please calculate. So number of moles of C2H6O2. This will be equal to 20 grams divided by what is the molar mass for C2H6O2? 62 ना?
Yes, sir.
yes, sir, 62.
24 plus 6 plus 32 है ना? चलिए, एंड वाटर का क्या हो जाएगा? 80 अपॉन 18 grams per mole. ये भी आपका क्या आ जाएगा? 4 point, will be somewhere around 4.44 moles, I guess. And what will be this? ये आपका 1/3 1/3 मतलब 0.32, yeah,
Yes.
0.32 के करीब होगा, है ना? And you have to calculate the mole fraction of C2H6O2. This will be equal to 0.32 by 0.32 plus 4.4.
4.7.
4.7 नहीं, 4.44 होगा.
No, sir. 0.32 divided by
अच्छा.
4.4.
हाँ, ये हो जाएगा, हाँ, कंप्लीट मिला के हो जाएगा 4.76. What will be this amount? Tell me.
Zero point zero six
0.068.
67.
0.67 or something. Okay. 0.067 नहीं 68 होगा if you will approximate Shravya, okay. 0.067 के बाद जो भी नंबर आ रहा होगा ना to be higher than 5, 0.068. Okay. And now let us calculate the mole fraction of H2O. Jaldi. Let us see who gives the answer quickest. Mole fraction of H2O. Correct. अरे no Mohammed Saif, no. It will mole fraction में होगा, it will never be more than 1. It will be never more than 1. ठीक है. Mole fraction of H2 will be what? 1 minus 0.068. ये ऐसा हड़बड़ा है बिल्कुल ना, क्या बताएं हम. Yeah. So this will be how much? 0.932. Okay. 0.932. Yeah, correct. Abdul Rahman भी थोड़ा हड़बड़ा गया, 0.92 कह दिया उन्होंने. Okay, fine. But so today we learned about a lot of concentration terms, right? You have solution chapter. In solution we learned about concentration terms. The first concentration term that we learned about was mass percentage. Then we learned about volume percentage. Then we learned about what? Mass by volume, right? W by V. Then we learned about parts per million. After that, we learned about molarity.
Molality and mole fraction.
Molality and mole fraction. Okay. So if I talk about the concentration terms according to CBSE, so these are all the concentration terms that is there in CBSE. Okay. There are two more that we will discuss in the next class, that is normality. And there's another one which is known as formality. Okay. So we will discuss this in the next class, normality and formality, and also we'll be doing, first of all, we'll be doing more questions on these type of, okay, on all of these 7 that we have done. We will do some more question interchanging these things, okay, interchanging these things. And also we'll be deriving a relationship that we derived in the 11th standard also, that is the relationship between molarity and molality, okay, relationship between molarity and molality. And you also saw a trailer of this in this question. Okay, this question, it has a trailer, okay, because here you have been given the, what is given here, volume is given and the mass is given. So you can directly very easily find out the molarity. And if you have the molarity, then how to use the density and all in order to calculate the molality of the solution. We will also discuss the relationship between molarity and molality. Okay.